Hey y'all, today we're going to continue on with right triangles and also with trigonometry, and we're going to do something we could call solving right triangles. The first thing I want to show you is a calculator. So on our calculator we can find trig values. So sine, cosine, and tangent are functions. That means I can plug a number in and I can get a number out. So the first thing I want to do is hit the mode button. And I'm going to go down to where it says radian. And I want to make sure over here, like I have it right now, the word degree is highlighted. So that means my calculator is in degree mode, and that's what we want because we're dealing with degrees. So now I want to show you a couple examples. In the last lesson we wrote the fractions that represented sine, cosine, and tangent of an angle. And we didn't know what that angle was, but we could still write sine, cosine, and tangent because we knew the sides of a right triangle. Well, sometimes we know the angle, but we don't know the sides, and we could still find sine, cosine, and tangent. So, for example, this time if I know the angle is 73, I can find out what the sine of 73 is without knowing the sides of that right triangle. So in my calculator, I just go to where it says sine right here, S-I-N, or sin, a lot of people like to call it. I press sine, type in 73, and close the parentheses, and hit enter. The sine of 73 degrees is approximately 0.956. That means if I knew the side lengths of a right triangle, and I was trying to find the sine of an angle that is 73 degrees, the fraction that I would write, if I actually put that fraction into the calculator and divided, it would give me a decimal of 0.956. So we're going to use that idea here and some of what we did in the last lesson, and we're going to find missing sides in right triangles. Now I know some of you don't have calculators at home. I think Apple or Android, they do make pretty cool graphing calculator apps. I'm pretty sure they're free. So if you have a smartphone, you have that opportunity. You can download them. If not, you might have to only get to a certain point on these problems and then use a calculator in class to finish. So here I have an angle of 73. I have one side and another side. And I don't know what this one is. And that's okay because we don't need it. So the first thing I want to do if I want to find x is I'm going to look at the angle I'm given, 73, and I'm going to label the sides of the triangle opposite, adjacent, and hypotenuse. So the side opposite of 73 is over here. My hypotenuse is across from my right angle. And that leaves my other side as the adjacent side. So now I look at my triangle and I look at the sides and how I just labeled them. The side labeled x is my adjacent side. The side labeled 6 is my hypotenuse. Back from last lesson, the trig ratio that had the adjacent side and the hypotenuse in it, that was cosine. So I'm going to say the cosine of 73, that's the angle. We know the angle, so we're going to use it. The cosine of 73 is equal to the adjacent side, which is x, divided by the hypotenuse, which is 6. So that's using what we just talked about at the beginning of this lesson and our cosine ratio from the last lesson. The only difference here is we don't know this adjacent side, but we do know the angle. So now we have an equation to solve. I'm going to divide this by 1. Anything divided by 1 is still the same thing. And now I have a proportion like we've been working with recently, and I can solve for x. So I'll multiply x times 1 is x, and then 6 times this whole thing, cosine 73. Like we talked about at the beginning of this lesson, when we did the sine of 73, it was just a decimal. So cosine of 73 is some decimal that we don't know just yet, but it's just one number, so it stays together. So on my calculator, I can do 6 times cos 73, and I get that x is approximately 1.75. And that should make sense because the hypotenuse is 6. 1.75 is smaller than 6, which it should be because the hypotenuse is the longest side in a right triangle. And you can see that this side is the shortest side in this right triangle. So 1.75 seems like an appropriate answer. So I want you to pause here. So press pause. I want you to find x. I'll give you a hint. Start by labeling your sides opposite, adjacent, and hypotenuse according to this angle of 24 degrees. So press pause now and find x. So you should have pressed pause and labeled that this side was the opposite side. This side is the hypotenuse. And this side over here is the adjacent side. So I have x as my opposite side and 12 as my adjacent side. Opposite and adjacent, those two values make up tangent. So I can say the tangent of 24 is equal to the opposite side, which is x, over the adjacent side, which is 12. And then I'm going to use my, I don't want to call it a trick because it's not a trick. It's just mathematically correct. I'll divide this side by 1, and I can cross multiply. 1 times x gives me x. Then I have 12 times this whole thing, tangent of 24. So now if you don't have the graphing calculator at home, you don't have an app, or if you don't have a calculator on your smartphone that has tangent, then you can stop here. But I'm pretty sure that most phones, if you turn them sideways, you can get sine, cosine, and tangent. So just check that. It's best that you practice. So now I can just do 12 times tan of 24. And I get that this side is approximately 5.34. Again, if I look here, this side was 12. It's clearly longer than this side. So 5.34, that seems like a pretty good answer. So I got one problem for you to try. Use the other two as your examples. If you have to, go back and rewatch my explanation of those examples. I want you to actually try this. If you get it wrong, that's okay. Just ask a question in class. Find x. My hint to you is to start by labeling the sides opposite, adjacent, hypotenuse, according to this angle of 37 degrees.